Hi guys. So today, area and volumes of similar solids. Similar. That's the key word here. Let's see if I can make this a little bit more legible. One day I'm going to get a little bit more technologically advanced, and hopefully you can see. Okay, so similar solids have exactly the same shape, but not the same size. The same shape, but not the same size. All right, two solids are similar if the ratio of their corresponding linear measurements are equal. What are linear measurements? That would be the length, the width, the height, the slant height, going down the side of a pyramid. If you were to slide all the way down, that would be your slant height. The perimeter, the radius, diameter, and circumference. These are all types of linear measurements. And if those are equal, then you can say that the figures are similar. Okay, so let's look at this figure right here in number 1. And if you notice, these two parts correspond. Those would be the two height of those rectangular prisms. And what I'm going to do is I'm going to do 12 over 3 because there's a 12 and there's a 3. And I want to see if they all reduce to the same number. So 12 over 3. All right, there it is. The next thing I'm going to look at is this side, just the ones with measurements they gave me. There's no real science behind it. I just need to compare the corresponding sides with actual measurements. All right, so that would be 20 over 5, and that reduces down to 4 over 1 as well. And then this last side with their measurement, 8 over 2, and that also reduces to 4 over 1. So yes, all have a scale factor of 4 to 1. And are similar. Woohoo! Okay, so why don't we look at number 2 and determine if they're similar or not. Let's go ahead and start with this side this time. And we'll do 6 over 10. And we'll reduce that, and we will get 3 over 5. And then we'll do this side right here. And that will also be 6 over 10. So of course that's going to be 3 over 5 as well once you reduce it. So far it's looking similar. And now our last one, 8 over 12. Well, we reduce that and we get 2 over 3. That does not match. So no, these two figures are not similar. Not all of the scale factors are equal. So they can't be similar. Okay, I'd like you guys to try this one on your own. And then let's look at this last bit, comparing volume and surface area. Okay, so if we know that two solids are similar with a scale factor of A to B, then their volume and surface area ratios are as follows. Well, area we know is A squared to B squared, and volume is A cubed to B cubed, right? Those are the dimensions in which we measure them. So, Mrs. Black, what exactly do we do with that? Well, it's not too bad. Let's look at an example, and we will do it together. So here's our example. And this is a bit long of a problem, so bear with me. Actually, you know what? I think I'm going to use my already written one. Okay. The lateral area for two similar cans of slime is 1,019 centimeters squared and 425 centimeters squared. The volume of the smaller can is 1,157 centimeters cubed. What is the volume of the larger can? All right, so what we're going to do is we're going to go ahead and we're going to set up our scale factors. So we're going to take the first two that they actually gave us, the two to compare, 1,019 and 425. And then remember, if we're talking area, it's always squared. So we need to get it down to its normal original scale factor. And by doing that, we're going to take the square root. So we're taking the original scale factor they gave us of slime, and which was in area, and we're going to bring it back to the basic scale factor by taking the square root. All right, so when we do that, we get 31.92 and 20.61. That's your original scale factor, okay? So now we want to set this equal and cube the scale factor. What do you mean by that? Okay, well, I want to go ahead and set them equal to each other. So I'm going to take 31.92, cube it, and set it over 20.61 and cube it, right? We have to cube it because we're looking for volume. What is the volume of the larger can? All right, I'm going to put the smaller can on top because that lines up with my smaller scale factor over the volume that I know of my, oh, sorry, I'm putting the larger on top and the smaller on the bottom. Because I know my smaller volume, I'm trying to figure out my larger volume. And then I'll cross multiply. All right, well, actually, first I'm going to cube this, and I'll end up with 32,522.85 over 8,754.55. And then I get to cross multiply. And here is my wonderful number. 8,754.55x equals 37,000. Hold on, let me put some commas in here so I can actually read this number. 628,937.45. I'm going to divide by this number on both sides, and I'll end up with my volume equals 4,298.21. Whew. Goodness, I cannot read numbers this morning. I apologize. Anyway, so we will definitely do a few examples like this in the future so that you can get the hang of them. They are a long process. And that's your video for today. Sorry, it's a little bit longer of one. Bye, guys.